Hello, everybody, and welcome to the Astro Show, place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from an aerospace doctor, find out what astronomers have to say about life, and learn about what's happening up above your head, all in the same place. So, we hope you join us the second and fourth Tuesdays of every month at 6 p.m. Mountain Time, typically on Twitch, Facebook, and YouTube. Tonight, just on YouTube, so we hope you are joining us there. Remember, you can call in and ask your questions. This time, just through YouTube, but we'll get back to live call-ins sometime soon. Our special guest tonight is Dr. Mark Richardson, the Education and Outreach Officer at the McDonald Institute, based at Queen's University. Among other things, Mark has held research and educational roles at the American Museum of Natural History in New York City, as well as at Oxford University, with research focused on simulating galaxy formation and evolution and understanding how people engage and learn at science museums. We'll hear all about that later on this evening, but before that happens, let's welcome our co-stars. First, author, journalist, and creator of the Space Tourism Guide, it's Valerie Steinbeck. Oh, you're muted, Valerie.
Sorry, I didn't realize. Thanks for having me. Glad to be here.
Happy to have you. Next, astronomer and data visualization engineer at the Adler Planetarium, it's Dr. Lauren Corlees.
Hi, everyone. Good to see you.
Hey, Lauren. Good to have you with us. And we are hoping to have Dr. Danny Carroll with us later tonight. She is on call as a surgeon in her residency at the moment. So hopefully everyone fares okay tonight, and she'll be able to join us a little bit later on. All right. Well, we are going to get started with tonight's show with Astro Advice, life advice from astronomers and other scientists. So as always, co-stars, I'll read the quotation for you, and you'll get to select who of the four possible quoters actually made this quotation. So here it is for this evening. One lesson astronomy tells us is that we're a tiny mote in a hostile void, and help is too far away. So, the options for who actually said that are A, Helen Sawyer Hogg, who was an American-Canadian astronomer who pioneered research in globular clusters and variable stars, and was the first female president of several different astronomical organizations. That's Helen Sawyer Hogg. Option B is Sandra Faber, American astrophysicist, known for her discoveries linking the brightness of galaxies to the speed of stars within them, and was the co-discoverer of the Faber-Jackson relation. She is the University Professor of Astronomy and Astrophysics at the University of California in Santa Cruz, and works for the Lake Observatory. She was also instrumental in designing the Keck telescopes in Hawaii. So option B is Sandra Faber. Option C is Margaret Burbidge, the British-American observational astronomer and astrophysicist. In the 1950s, she was one of the founders of stellar nucleosynthesis theory. During the 60s and 70s, she worked on galaxy rotation curves and quasars, discovering the most distant astronomical objects then known. In the 80s and 90s, she helped develop and utilize the faint object spectrograph on the Hubble Space Telescope, and was well known for her work opposing discrimination against women in astronomy. And finally, Option D, Nancy Grace Roman, American astronomer who made important contributions to stellar classifications and motions, the first female executive at NASA. She served as the first chief of astronomy through the 1960s and 70s, which established her as one of the visionary founders of the U.S. civilian space program. So, again, here is the quotation. One lesson astronomy tells us is that we're a tiny mote in a hostile void and help is too far away. So, Lauren and Valerie, who do you think actually said that?
So I don't know, but my guess is Margaret Burbage.
Okay, one vote for Margaret Burbage.
I was secretly hoping that one of their experiences and contributions would give a hint, and there were no hints.
We're not going to make this easy
No,
for
it was
you.
well done. Well done. I'm going to go with Nancy Grace Roman. I felt like hers was the most aligned with the quote, but we'll find out.
We will indeed. The correct answer was actually Sandra Faber. So, sorry, no points for either of you at this time, but that's okay. The news quiz is coming up, so you have all kinds of opportunities to make points then. But yeah, curious what the two of you think about this quotation.
Yeah, I think for me, I've been working on a new project related to climate change and like what's happening to the Earth. And a common thing you'll hear people say is like, "Oh, well, we have to find a way to get out." Like there are no other options. It's just not possible. Yeah. We have this one planet, and so that's what it's funny that she's like, "This is the quote." 'Cause this is sort of what I've been thinking about this past week.
Yeah, people. I just did an interview last week about space colonization. On the moon and Mars, and probability of people living there in 10 years, 20 years, 30 years. Yeah. And I said, yeah, I think there will be people living there, but you have to remember that there's no place out there like home. Like everywhere else is going to be way harder to live than right here on Earth. So keep that in mind as we start exploring space.
Yeah, it reminds me of that, the show For All Mankind, which is sort of an imagination of space exploration. I believe they're only kind of just now approaching the modern day in the show, but there's a moon base for decades and there's still just a moon base. It's not like there's a moon base and moon houses and moon yards and, they're still just living in the same confines because we can only recreate our necessary environment in small controlled areas, and that technology that's the way it'll be for a long time. So yeah, I think if there's any help, we're going to have to engineer it here on Earth. There's not going to be some magic solution that comes from outside.
Yeah. As much as we'd like to complain about the weather and inhospitable areas on the Earth, it's still way more hospitable than so far anywhere we found. Literally
anywhere else.
literally anywhere in the entire universe. Maybe in the multiverse. But as Sandra Faber points out, there might be some nice places, tens of thousands of light years away. Shoot, maybe even just 1,000 light years away. But we're not going to get there, most likely. You never know. Any other thoughts on this?
I think this quote also, the other part that sticks out to me other than the help is too far away is the tiny mote in a hostile void. And I think of a dust mote kind of floating in the air in the sunlight, and how that when you see that, it kind of changes your perspective of how big and small things are. And a dust mote that's visible to the human eye is actually quite a large piece of dust. And just so to think of our planet in the same sort of perspective and context is humbling, which is what I've always loved about astronomy, is that it keeps me quite humble about my own. I'm a tiny mote on the hostile void that is planet Earth in the human race, and our planet is the same in a very large universe, and I kind of like that perspective. I always like having that reminder.
Yeah, you were talking about that famous picture, pale blue dots that came from Voyager. I think pretty soon after it launched, just a few years after launch, and it turned back and did a portrait of the solar system. And yeah, at first I couldn't find the Earth, but then, yeah, in a sunbeam, there was this tiny little speck that turned out to be us.
We'll be getting some photos like that from the Artemis mission, and
Yes.
we're much bigger in the photos, and it's still humbling to put us in our perspective of what's outside the atmosphere, which is not a whole lot.
Yeah, not a whole lot. Turns out the vacuum of space is not a perfect vacuum, but it's still pretty vacuumy. It's not a lot going on there, unless you're dark energy, and there seems to be plenty. All right. Well, if there aren't any more comments about this quotation, we will move on to Astro 365. This day and week in astrophysics history. So it is true that in 1977, on this day, the supersonic Concorde began scheduled flights between Paris and London to New York's JFK. But 4 years after that, on this day, I was born. So before we get to the Concorde jet, here's a shout out to my mother. Thank you for bringing me into the world. Cheers, Mom. Appreciate that. Yeah, today is my 41st birthday. And yeah, I did not know that I shared a birthday date with the Concorde, but learned something new every day. Unfortunately, I think for a lot of us, what we remember about the Concorde jets is the terrible disaster in 2000 when the Air France Concorde crashed shortly after takeoff. But what I didn't know about the Concorde jets, which is much more uplifting, pun intended, was that before they actually started commercial flights for passengers, the Concordes were actually used for some scientific missions. And in 1973, one of the Concorde jets set the current record for the longest observation of a total solar eclipse. They were able to observe the eclipse for 74 minutes, traveling at supersonic speeds, which is pretty good compared to the 4 minutes we got in 2017. So yeah, the Concorde jet still holds the record for longest duration of an eclipse viewing.
That's really cool.
Yeah, 74 minutes, and that was in 1973. And then, yeah, of course, the Concordes got discontinued. I did a little research into why that happened. It turns out it's pretty complex. Part of it was the disaster in 2000. It turns out it probably wasn't Air France's mistake. A previous jet that had taken off that morning discarded a little piece of scrap metal, which popped one of the tires of the Concorde jet upon takeoff, which then punctured one of the fuel tanks, which caused a fire, which caused the engine shut off, which caused them to crash. But anyways, it was a big black eye, and because of financial reasons and the realization that they could actually make more money by just selling business class and first class tickets on subsonic jets, the Concordes were eventually all discontinued. But it got me thinking, right? So they were supposed to be like the new, biggest thing, with travel 40 years ago. And, I found myself thinking, all right, so where are we going to be 40 years from now? What is going to be the new big way of travel 40 years from now? And I thought it might be fun just to make some predictions. It being my birthday, and hopefully 40 years from now, I'll still be around, and we can all get together and have a drink and talk about whether it actually happened or not. So Valerie, Lauren, what do you think? Are we going to be in spaceports in 40 years, or are we going to still be doing airplane travel? What do you think?
I'd love for there to be spaceports, but 40 years seems like maybe not enough time. I don't know. You could always be surprised.
Yeah, I think that what I am seeing here, it's funny when we were talking about, this almost 50 years. If we think, it's almost 2023 as we're recording. This was, you said 1973. That's 50 years, which is crazy. Then there's sort of this cyclical nature that ideas which sometimes start, it takes a few decades and they might go away and then come back. So I was actually wondering, what are we doing now that we're not doing very well, that we will have abandoned and then come back with better technology? Because I believe it's United that's supposed to start supersonic flights again in the next few years. So it's kind of coming back around as we hit this 50-year mark. So hopefully we'll see suborbital transit. That'd be great. But I'd actually just love to think about like super sustainable electric options for everything. Wouldn't that be nice? Electric planes, electric boats, electric whatever, electric trains, all of that. There's no reason that we should not be very good at that technology in 50 years, 40 years.
Yeah, I mean, we're already kind of seeing a cycle of that, right? With the Tesla. I mean, the first electric cars, I think, were over almost 30 years ago, right? Wasn't that the 90s when the first ones came out?
I think Toyota released their earliest ideas of their what became the Prius. I somehow know this history, but the US was supposed to be rolling out these laws that were going to force all vehicles to go toward electric, and Japan's manufacturers took it seriously and developed the technology, and all the American companies just lobbied to get the laws delayed and then overturned eventually. And so that's why the Prius was one of the first hybrid vehicles. So the Japanese automakers, Toyota, was saying, well, we have the electric technology, but we don't need full electric, so we'll go hybrid and we can kind of keep moving in the electric direction. I don't know why I know this trivia, but I think it was in the late 80s that they were developing that, because there was the early 90s, those laws were supposed to go into effect.
Yeah. But California passed a law like that recently again, right? California specifically. Yeah, I know. But I'm starting to see it. Like, I was just listening to something on NPR, and here were commercials from Chevy being like, we're rolling out an electric truck. Like, I think it's gaining more momentum now, which is really exciting. So
finally seeing the mainstream US manufacturers building electric vehicles, purpose-built, saying, oh, you want a good pickup truck for all your adventure? Here's an electric version that's even faster to accelerate and, cheaper to operate. And that's great. That should get everybody on board.
Yeah, so maybe we'll have really good, affordable, suborbital space tourism in 40 years.
I'm also really hopeful for just better trains. Like, the US used to have a lot better of a trolley and train
trains
system,
at all.
and then we moved to cars, and cars are terrible. Let's just take trains.
We'll catch up to where Europe was 70 years ago, 40 years from now in the United States.
Or just do better. Get the new technology, build more rails. And I was thinking supersonic, you can cross the country pretty quickly on a train. So, I don't know. That's what I would love.
I think that's a good call.
Yeah.
This reminds me of the quote that we had a few episodes ago that was about how humans underestimate our capabilities in 100 years, but overestimate our capabilities in 10 years. And we're kind of in between, and we're kind of being conservative. Like, why can't we talk about hover vehicles and stuff? 50 years ago in the 70s, they were creating the Jetsons, right? They were thinking we have flying cars right now. So
I actually talked to an engineering friend of mine about this. So think about how difficult traffic is to deal with in 2 dimensions. And now imagine dealing with it in 3 dimensions.
Yeah.
That is why we don't have
yeah. Given how bad drivers are in 2 dimensions, it's going to be a nightmare when there's going to be so many more rules that nobody follows.
Apparently
we are flying trains then. No one we get the best of both worlds.
Apparently dealing with 3D traffic is a really difficult engineering problem.
Oh yeah.
But maybe we can have a show about that. That might be a lot of fun. We can hunt down an engineer who's actually planning that out. I'm sure they're out there. Yeah. So if you're listening right now, or if you're listening to this recording and you happen to be that engineer, drop us a line. We would love to have you on the Astro Show. All right, well, we should get on to the astronomy news trivia quiz.
The most stressful part of my week.
Awesome.
Every time. It's fun, but it's also stressful. It's like a pop quiz that I know is coming. It doesn't make it any less stressful.
It's okay. We don't. I just totally dropped the name of those author scorecards that we talked about a few weeks ago. Your H index.
Yeah.
You will not put your scores for the quiz on your H index, so don't worry. This goes on nobody's permanent record, although it is out there on YouTube on the Wyoming Stargazing channel. But you can always like black out a section if you really want to. Anyways, so we the first three questions were for Dr. Danny. So we'll do those like the first three popcorn style. Whoever can answer them first, and then we'll get into Valerie's questions and then Lauren's questions. All right. So are the two of you ready to try to steal points from each other here? Okay, here we go. All right. Okay. Question one. Which NASA mission captured a selfie with Earth last week? After Valerie.
It's Artemis.
It's Artemis.
Finally.
Yay! We finally get a picture of the entire Earth again. I love it. Yeah, nice job, NASA, on this one. We finally got Artemis off the ground, and yeah, it's probably, is it orbiting around the moon already? I think it probably is.
It released the CubeSat, so yeah.
Yeah, I think so. So very cool stuff. And yeah, I am stoked about the first woman stepping foot on the moon in under 2 years now. Very cool stuff. All right, so we got 1 point for Valerie. All right, next question. Are you ready? Here we go. What is the official name of the mannequin that is in the Orion capsule? And as an extra point, who is the mannequin named after?
I saw this because I was watching the NASA live feed and they explained the whole thing, and I can't remember. But I remember that was what they were telling me about. I don't remember though. Oh, now I'm mad.
Valerie, anything?
I didn't even know there was a mannequin. Somehow all of my news sources they're not focused on the mannequin.
There is a mannequin, and his name is Commander Munikin Campos.
Munikin, that's right.
Yeah, not super fancy. So Munikin, obviously, right? We got that. He's a commander, only person up there, so he's got to be the commander. It is a he, apparently. They've been using a male mannequin during all the testing so far. But the name Campos comes from Arturo Campos, who was a systems engineer during the Apollo 13 near disaster and was instrumental in actually getting those astronauts home. So in honor of his work, they named this mannequin after him. And NASA has this whole website of like the adventures of Commander Munikin Campos. That's where this picture comes from. So you should, type in Commander Munikin Campos. And if you look closely, do you see what's in his visor? It's these three white stallions. And I don't totally know what the three white stallions are about. But if any of you out there listening know, you could chat your question, and we would love to find out the answer.
I'll take a guess that it might be the horses pulling Artemis's chariot. That would be I don't know if there are horses, but that's my guess.
I like it. I bet that's what it is. We should probably give you a point for that because you're probably.
I don't know if that's right or not. So.
All right. One more question on Danny's reel, and then we'll get to the real news quiz here. All right. Third question. What landed at Kennedy Space Center in Florida on Saturday after nearly 2.5 years in orbit? I had no idea that this even existed. And apparently that was the idea.
Oh, so they did there was a good thing that nobody knows the answer to this one. We're not supposed to know about it?
Well, I mean, it's news now, but before the landing, it wasn't news.
I do not know.
Okay, so this was a secret U.S. military space shuttle drone.
Space shuttle drone?
Yeah, this thing has been in orbit for 2.5 years. It's gone over, like, I can't remember how many billion miles. And it's just been doing scientific experiments and collecting data and doing its thing up there without anybody knowing about it except the U.S. military. But it's back on Earth now.
The trickiest thing I learned this week. Also the most unsurprising. It's both surprising and unsurprising at the same time.
Right. Yeah. So yeah. That's what it looks like. Just like the real space shuttle, but smaller. I think it's like 30 feet long. But yeah, a sizable drone, and it's been orbiting around the Earth.
That's so cool. Makes me wonder what, when Russia and Roscosmos and China both send up secret stuff, what are they sending up? Cool little things like this? We'll never know until they land.
I wonder if they've retired this, what's up there now, because you don't just bring something down without having a replacement. So there's something different up there now too.
Yes.
Yeah.
All right, so Valerie, you picked up 1 point there for sure. We're not sure about the second point, so we'll just we'll call it 1 point. But now we've got 3 real news questions just for you, Valerie. Are you ready?
Yeah, as I'll ever be.
No pressure. Okay, here we go. Which satellite became 40 times brighter last week after its antennae array unfolded?
I do not know. I can just
okay. I didn't either until I read the news story this week. It's called Blue Walker 3. It went from like 4th magnitude to 1st magnitude.
Wow.
Or to like 0. Yeah, a 40-fold increase. It's got this enormous antenna array. And this is one of 100 that are going to be launched in the next decade. They are going to be the brightest satellites out there.
Do you know what it does?
I do not know what it does. It was not in the article that I read.
Yeah, that's so bright. That's so, it's the future, but it's
it
so
almost
bright.
outshines every star, any star in the sky. There's just a few stars that are brighter than Blue Walker 3.
So far, this week's quiz is just a testament to how much is going on in space science that nobody knows about. Like nobody's really paying attention to this stuff, which is really cool.
I mean, everyone's been like so concerned about the SpaceX Starlink satellites. These are nothing compared to these.
Yeah.
The Starlink satellites, I think they're like 30 times less bright than these, if that.
Yeah.
So yeah, Blue Walker 3. Watch your skies for them. Okay, number 2. What is the name of the astronomer at Williams College who spent more than 50 years traveling the world, watching eclipses, and with 74 sightings under his belt, probably has more than any other human being in history? Unfortunately, he passed away on Sunday at the age of 79.
Again, I do not know, but I am very impressed with the ability to see 74, given how frequently there are solar eclipses to view.
Right, so that means he was seeing more than one a year.
Yeah.
For 50 years. Here is the gentleman, Dr. J.M. Pasachoff. The all-time world record holder of all of human history for the most eclipses seen, with 74.
Life goals. Man, that's awesome.
Yeah, that's so cool.
Yeah, not bad at all. Okay, last question for you, Valerie.
Let's see if I can get a point.
All right. What splashed down into Lake Ontario in Canada last Saturday, just a few hours after being spotted?
I do know this, and I don't know if it has a name, but it was a space rock. They just spotted a space rock, and then it entered like very soon afterward.
Yeah. So only the 6th time this has ever happened that an asteroid has been found just hours before it entered the Earth's atmosphere and then disintegrated. But yeah, it happened just over the weekend and landed in Canada, in Lake Ontario. So you got a point there. All right, 2 points for Valerie. All right, Lauren, you need 2 to tie and all 3 to win. Are you ready?
Let's do it.
I like that enthusiasm. Recently uncovered from Gaia data, a Sunlike Star about 1,600 light years away is believed to be orbiting around what every 186 days?
I don't know.
I'll give you a hint, but then you'll know for sure. Keep it simple.
I mean, there's a lot of things. That's why I don't know. Is it a red giant?
It is not a red giant.
A black hole?
It's a black hole!
I just keep guessing. It's some kind of
I'm going to say you can't actually see it. Yeah. So this is the first time that a Sunlike Star has been observed, we think, orbiting around a black hole. And it's like in our stellar neighborhood, it's 1,600 light years away. That is not that far in the long scheme of things. So yeah, Sunlike Star, which is pretty cool.
Yeah.
All right, 1 point for Lauren. One more to tie, 2 more to win. Here you go.
Guess.
We now know that which galaxy has a galactic halo that is a wobbly ellipsoid whose 3 axes are all different lengths.
Wouldn't that be all galaxies?
Well, this one, yeah. So this is, I guess, one of the first ones that has been confirmed. The actual shape of the galactic halo. It was believed to be mostly perfectly spheroidal and symmetrical, but not the case.
Not sure.
I'll give you a hint. Give you a hint. So this data all came from Gaia as well.
Then the Milky Way.
It was the Milky Way!
I was like, it has to be a close by galaxy.
Yeah. So it turns out our galactic halo is not a nice sphere encircling the galaxy. It's this oblong kind of football shape, and it's believed to have happened that way because of galactic interactions over the last 10 billion years or so.
Yeah.
Do you know the name of the really big galaxy that what they're calling it that merged with us about was it like 8 or 9 billion years ago? I didn't know it had a common name. It has to do with Gaia as well.
No, what is that? The Milky Way's had a lot of mergers, so.
This is called the Gaia Sausage.
Oh. That's funny.
The merger with the Gaia Sausage is believed to have been the largest contributor to the oblong shape of the Galactic Halo.
Cool.
Yeah, I did not know that.
No. I assumed it was ellipsoidal, but yeah, that's cool that they've been able to track it down to one major merger event. That's neat.
Yeah. Okay, we are all tied up. 2-2. Lauren, for the win. Are you ready?
Ready.
Okay. Which telescope won't get renamed after community pushback about its namesake culpability in anti-LGBTQIA actions?
Yeah, I saw this headline. This is JWST.
No longer known as the JWST in terms of Wyoming stargazing's repertoire, we are now going to call it the Margaret Burbage Space Telescope, the MBST. NASA did a whole lot of things right in getting this telescope into space. My humble opinion is that they got the name dead wrong, and the way they've handled this whole appeal, I believe they've gotten wrong as well. Love to hear your thoughts on it, both you, Lauren, and Valerie, and I'll say a few more words as well.
To me, they've just had multiple opportunities to make it some boring, bland name that wouldn't offend anybody sideways. But anymore, changing anything's name offends somebody. They could have called it the Gaia Sausage and someone would have been offended. So doesn't really surprise me, but it's also disappointing for an agency that I think does a generally good job of encouraging talent to name such an important piece of technology after someone who would not have supported those people in the agency.
Yeah, and it really seems as cut and dry to me as well. just like that. They had a golden opportunity to do the right thing, and they couldn't muster the gumption to do that. I don't know. I don't get it.
No, I completely agree. It's incredibly disappointing, which is why I always refer to it as the JWST. So at least the name is minimized as much as possible. So.
Well, I think Margaret Burbage did some pretty amazing things to work against discrimination against women at NASA. So I feel like it's a pretty fitting name for this telescope. So yeah, at Wyoming Stargazing, we're going to call it the Margaret Burbage Space Telescope, and maybe NASA will get the hint and maybe they will change it at some point later on down the line.
The nice thing too is by calling it the Margaret Burbridge Space Telescope, every time you say that, you're going to have to explain. And then people are going to get to know who she is and what work she did. And that is a really powerful opportunity.
Exactly, right? And that's exactly why we're doing the Astro Advice, right? And highlighting these folks who don't get a lot of airtime, whose names that people don't even really know for the most part outside of very small astronomical circles, but it made monumental contributions to our understanding of the universe. And they deserve some credit, a whole lot of credit, actually. So we're going to do what we can in getting the word out there about the Margaret Burbridge Space Telescope. So with that, it is time for our guest spot.
Wait, Lauren won. We need to acknowledge that.
You're right. Lauren, you are this week's champion with 3 points. Congratulations, Lauren. Thank you, Valerie.
Thank you.
I am remiss. And I don't know how I always do this. I always skip the what's up, Dr. Sam, and there's like an important one today because it's actually what's not up, Dr. Sam. I thought it would be fun to talk about sun signs and constellations of the zodiac, right? It being my birthday, I'm a Sag. Scorpio ended yesterday. Sagittarius begins today. But it's not a constellation that you will see up in the night sky because it's your sun sign. It's the constellation that's up during the day that the sun is in front of or passing through in front of when you're born, as opposed to the constellations that are up at night when you're born. So Sagittarius is the archer. I don't really know where the Greeks or Romans got an archer in this lovely arrangement of stars, but it's known as the teapot. That's what people really see today. So there's a lovely picture of the teapot with just the stars, and then laid in with the Milky Way galaxy in the background. And it's very close to the galactic center. So when you're looking at Sagittarius in the summertime, and you can actually see it up at night, you're looking right in towards the center of the Milky Way galaxy, just up to the right of the teapot. You can kind of think of the stream of the Milky Way as steam coming out of the teapot. So the constellations of the zodiac, there are 12 of them, one for roughly each month of the year, and they are the constellations that the sun seems to pass in front of as we orbit around the sun each year. So this diagram shows you the angle at which we look out into the night sky and the stars that we see at night. And so certain times a year, we can see a certain portion of the sky at night. Other times a year, we see a different portion of the sky. Throughout the whole year, we get to see all 12 of these constellations that line up along a special line that we call the ecliptic. And so this map shows you that there are 2 special lines out there in the sky. There's the ecliptic and there's the celestial equator. So the celestial equator is the Earth's equator projected out into space. It's as simple as that. It's the imaginary line of the equator out there projected onto the heavens. Whereas the ecliptic, it's the path that the sun appears to take through the sky throughout the year. The reason those 2 lines are different is because the Earth is tilted 23.5 degrees with respect of our orbital motion around the sun. If the Earth was straight up, the ecliptic and the celestial equator would be the same line, and we wouldn't have 2 separate lines. But because we're tipped, you get one line that the sun and all the planets seem to pass through, and then the projected equator out into space. And here's another way of thinking about that right here. So you will not see Sagittarius right now because it's my sun sign. It's up during the day when I was born on November 22nd. And so you can do a little research online and find out your sun sign if you don't already know it, and learn about it. So with that,
birthday, Sam. We didn't get to say that.
Happy birthday!
Happy birthday!
Yeah,
I love birthdays.
I appreciate that. Yeah, it's been a good day. It's been a relaxing day, and I love doing the Astro Show, so it's awesome. All right, so we're running late as normal. So we want to welcome our special guest. That is Dr. Mark Richardson from the McDonnell Institute. Mark, thank you so much for being here this evening.
Thank you for having me. I'm having a lot of fun on the backstage, and now, I'm excited to hang out.
Yeah, you already got a shout out from one of the folks watching the show, so there you go.
Hi, Corey.
All right, well, Mark, I know you've got some slides to share with us, and so I'll move those forward for you, and you just let me know what you want me to do.
Sure. Well, you said a few words about the research that I've been involved in, that I simulate how galaxies form and change over time. And I always like to kind of tell people, like, why do you simulate? Like, what does that mean? Like, you can go to these telescopes and get such amazing images. Why would you stay in front of a computer all the time? And so I wanted to kind of take a step back, and I thought I would try to impress on everybody, like, why it's fun to also use computers. And so to me, it all comes down to, like, what is an astronomer, right? So an astronomer is somebody that like wants to understand the universe. How does it work? Ask the big questions. Where did we come from? Where did it all come from? Why are we here? How did we get here? And so, we are at the heart, we are scientists, we're physicists, we want to understand how everything happened. But the universe is like one of the worst experimental labs to use. Things happen on scales too big to go and kind of check out. They don't fit in my lab. They happen on time scales way too long. So I can't have students sit around and watch to have things happen. And so we're kind of stuck between a rock and a hard place. And so what I like to think of us as is and maybe you can go to the next slide, it's just we're detectives then that really can't go to the crime scene, right? We have to kind of, yes, Sandra Faber, we are on a moat and we are isolated from everything. And so it's really, really cool that we have built technology that can try to get us a little bit of the way there. And so, the universe is so big, but maybe we can go out and try to just kind of appreciate what we can see. And so if you go to the next slide, there's kind of two ways that we can try to do this. And one is you just observe a lot of the universe. We build telescopes all over the world. So I have pictures of Mauna Kea, so Gemini and other observatories that are there. Arecibo, rest in peace, is a radio telescope that allows us to look in other wavelengths. So we don't even have to use our own eyes. We can use other light wavelengths to observe the world too, and see the world or the universe at different places and kind of get a census almost of all the different ways galaxies can be seen or all the different ways things happen. And instead of waiting millions or billions of years for it to happen, you see instances of it happening over here and there and there. And then us as detectives, as sleuths, have to kind of piece things together to try to understand. Is what's happening over here the same thing that happened to this other galaxy, but maybe a couple million years ago? And maybe this galaxy will someday look like that galaxy. And of course, we go to space to do this too. So if you hit enter again, we have Hubble, we have the Bridge Space Telescope. These are now new facilities that let us go and look at all these things. And, really, it's kind of like looking at pictures of elephants. Sometimes you see a kid elephant, sometimes you see a grown-up elephant. They look a lot alike, but what we can do if we can't sit around and watch their whole lives is try to understand what their life is like. That takes you from baby elephant to big elephant, or baby galaxy to big galaxy billions of years later. And so that's good, and that's what a lot of astronomers do. But you can't see every single thing that's happening. You can't know for sure that all those pieces in that timeline actually nicely fit together. And so there's a nice complementary work that we can do as astronomers, and that's using computers to fill in those holes. And so if you hit enter again, the other way is, first assume that we understand how physics works. This is not a very good assumption, but if we start with that, then we can actually put those laws of physics into a computer and try to simulate these things happening. And so I have two pictures here. I have the Millennium Run, one of the largest simulations ever run at its time. And it is really, every dot of light in that picture on the left is a galaxy. And so you're seeing from a simulation actually remaking kind of the whole universe. They're recreating the large-scale structure of how galaxies are formed. But even within that, you can then do other simulations understanding how galaxies form themselves. And so this is one from a simulation that I'm involved in, trying to understand what galaxies look like. And actually, instead of me sitting around for millions of years to see these galaxies change, I can just hit play. Still takes months, maybe a year on a couple computers, but I can, certainly get to see everything happening in between. And I can compare those with what the observatories see, and where they agree, that then I can understand maybe what's actually happening. Where they don't agree, then I'm told that I don't understand physics very well, which is fantastic. Scientists love being told they're wrong. And so when my simulations are horribly wrong, which is more often than not, then I get to say, okay, well, I don't know physics that well, and I throw out a little piece of it and try to improve my understanding. And then, yeah, you can hit enter again. Just, I show a lot of galaxies there, but this happens to even down to star levels. So we heard about a black hole. This is a magnetar, so a really magnetically driven star that's impacting the environment around it. And so people are simulating this to see how stars impact their environments. And so I'm trying to motivate, there are values here of both understanding or testing our understanding of how physics works, while also being able to maybe fill in those holes with a bit of Photoshop or whatnot to connect the whole story of what we see when you go to a telescope. So if you hit enter again, I particularly look at these simulations of galaxies, see how they interact with each other. I think we heard about the Gaia Sausage. These are things that happen. And, if we could somehow understand our current galaxy, maybe we can play back the clock using simulations to see the sausage happen. And I think I will probably just end it to say, well, maybe go 2 slides forward. There's a beautiful video that I don't think we have time for, but it shows one of those simulations of galaxies merging, and along the way it keeps comparing to real observations of galaxies, showing look, this galaxy that we made in the computer looks like these galaxies we see in outer space. And so we can assume that what's happening in our computer and the history that's embedded in that is present in what's happening in the real universe. And so this then allows us to use these simulations to ask big questions like this, like where do the galaxies come from? How do they form the stars? Why do they have different colors or whatnot? And how do they form stars? So these are the kind of questions that I get at in my research. And so I wanted to kind of set the field for the kind of research that I do.
That's awesome, Mark. Thank you so much. And hey, don't worry about not ending right at 7 o'clock. We never do that. We got time to play as many simulations as you want. It's all good.
Well, if anybody watching at home, one of your requests could be, no, play the video, and we can come back to it.
All right. Corey, we're going to count on you for doing that.
It's a good video. I like that one a lot. Yeah.
Well, Mark, thanks for that great introduction and for the importance of simulations. Very well said. I'm curious about how you got to where you are in your current position as an outreach officer, and how you got into astronomy. What were all the interesting twists and turns that got you where you are today?
Well, let me take you back to the 1990s. No, where it totally started for me was just the ability to see the sky. So I didn't grow up in a big city, but not far from a big city. I'm from Nova Scotia, from the Halifax area. But going out into the woods, going camping and seeing the sky above me. And I think that just kindled my kind of interest. I'm like, whoa, the Earth's really cool. But half of our entire world at night, when there's not light pollution, is the stars above me. And why are some stars red? Why is that thing? That wasn't where it was last night. It's Mars. It's moving. It's wandering across the sky. And then satellites and all these things just made me ask questions. And so that, and then sci-fi. I think watching Star Trek, watching those kind of opportunities for artists, for philosophers, for scientists to think about what the world could be, what would it be like to explore the universe, really made me want to be part of that. And so I always enjoyed mathematics and just kind of understanding how things work. And so that naturally took me to go into sciences, to go into astronomy. I did my PhD down in Arizona State, where the skies were amazing. you didn't have to look at the weather. You just knew every night you're going to see the stars. And then on to Oxford and on to New York and then here. But what happened along the way is I did a PhD, I did this research, but it wasn't enough. Yeah, this is the research I'm doing, but I want the public to care about what I'm doing too. I want, what the scientists are doing with the science that I'm doing. I feel like it's really kind of an inspirational opportunity to get the kids, to get everybody kind of caring about the fact that we do science, the important role that science does for our society. If you think about COVID, just how much we relied on science to overcome, arguably, whether we've overcome the pandemic or other, like climate change. Like, how are we going to face these obstacles? How do you take an X-ray at the dentist? Like, from everything in between, science is an important thing, and we need to make sure the public cares about it and cares that scientists are, continually finding opportunities to be proven wrong. And so starting even at undergrad in Halifax and then through my PhD, I was engaging with museums. I was engaging with the public. I was trying to find ways to make my science accessible to somebody that's, not doing the physics courses that I'm doing. And so that started becoming a much more common part of my work, both going on to Oxford and doing outreach opportunities there, and then certainly the museum. Like every day walking through that museum in New York, going to my office, and you're just seeing thousands of people and kids just like eyes wide open looking at fossils of dinosaurs and looking at giant planetariums. And so, yeah, that's what I really, really like to do. It's my passion. And so that brought me here to do that kind of work for the McDonald Institute in Canada.
I love it. Yeah, and that's why Wyoming stargazing exists, right?
Yeah.
Very cool stuff. I'm glad you're here.
Thank you. I'm really happy to be here.
Awesome. Well, the question that I ask everybody on the guest spot is, what's the one question that nobody ever asks you that you wish everybody does? So what are your thoughts there?
So, yeah, you told me in advance that this is a question you ask, and I had to think about it for a while and I have lots of thoughts. But I have to say, like, what's the question that really comes to mind is, what's your favorite science story? And it's a bit of a cheat. It allows me to talk for a lot longer to answer it.
I think story now.
But at the heart, I think even the nature of the question, right? It's like, I think people recognize that, you learn and you appreciate, and I think you get engaged through stories. And science is absolutely a story too. I think the most important way that we could be facilitating how we talk about science is the stories. Like you introduce, the most amazing women astronomers at the beginning of this section, and they all have amazing stories with them. And so I really like, I wish everybody would just be like, what's your favorite science story? Because it shows curiosity in science. It's an opportunity for me to tell a story here or there. And it just understands that that's the way that we communicate, is by telling stories.
I love it. Well, we're all about creating opportunities here, Mark. So, Mark, what is your favorite science story?
I certainly have a lot of favorite science stories, but I thought the one I would tell, just to be on theme, is the story of the very first galaxy simulation. And so I do have a slide to go with this. If you go to the next slide, I want to this is a bonus lightning round. Maybe, Valerie, you can get you can tie it back up with Lauren. So my question is, when do you think the first simulation of galaxies and galaxy interaction happened? When was this work done?
Okay, well, you've got light bulbs in there, so we know it had to be after the invention of the light bulb.
This is supposed to be a little bit less spoilery because those were going to appear later, but I didn't copy them.
I'm going to just throw a number out. I hope it's not like The Price is Right, but I'm going to go 1907 or something. Let's throw it back.
Mm-hmm. Any other guesses?
Yeah, I was thinking, late 1800s, early 1900s.
You guys are putting me to shame.
I thought it was something like the 40s and 50s.
So 40s and 50s what I usually hear, because when I talk about simulations, people automatically assume a computer simulation. And so you think of like Alan Turing and, another famous mathematician and scientist, really started that first idea of a programmable computer, something that you could make do whatever you want, which is what really is the beginning of everything that we use today. But if you hit enter, it was actually in 1941, so a little bit earlier than what most people say, but certainly later than some of you. But I think I see where you're coming from, because the actual very first machine computers, they do far predate this. Like they come back from 1822 by Charles Babbage, the first Babbage machine. It was able to, the giant machine weighed 700 pounds, I think, and it just was able to compute like quick multiplications and additions and just do simple things to solve these problems. But this did happen quite a bit later, but it did not require computers at all. This was a version of an analog computer. It was a computer that's basically built, custom made to solve this one problem. And so to do it, what Eric Holmberg wanted to do was, I want to understand what happens when galaxies interact. Do we get Gaia sausages, making our galaxy halo not spherical? Or what's going to happen when the Andromeda galaxy comes in and hits the Milky Way galaxy? But the problem with this question is each of these galaxies have hundreds of billions of stars. And, on top of gas, on top of dark matter. But if you just ignore those and you just look at the stars, as these galaxies come in, you have, for every star is feeling a gravitational tug from every other star in its own galaxy, from every other star in the other galaxy. And then you have to do that for every 100 billion stars. This is 1,000 million billion calculations you would need to do this right. I can tell you, even today, we don't really do simulations even with representing all of that. So Eric did two really cool things. He was first clever, and he's like, I bet you if I just use a far less galaxies, far less stars, I'm going to get more or less the right answer. I'm going to see the qualitative behavior that's going to happen between these galaxies. And so instead of hundreds of billions, he does two galaxies of 36, 37 light bulbs. The second thing was realizing light falls off with distance squared. So inverse R squared, if you've heard this before. So that means is if you take a light bulb and you move it twice as far away, it gets 4 times dimmer. 4 times less energy is fitting on or landing on a detector. And gravity behaves the exact same way. If you move the sun twice as far away, the gravitational force on that drops by 1/4. And so what Eric did was well, why don't I just build this thing and let light bulbs be the stars? And then instead of having to do even 74 by 74 calculations, I'll just replace each light bulb with a little measure, and the measurement it takes of the light is going to be directly proportional to the gravity you would feel if it was in a galaxy. And so it was just a matter of doing one calculation to find out what that proportionality was. And then he was able to do this. And then it was just 72 measurements rather than 72 times 72 calculations he'd still had to do. And so he was able to do this now on a much more reasonable time. And he was the first scientist to really discover that, the process of these galaxies interacting led to these huge spiral arms and these maybe tidal stripped stars, and stars could be flung out of the galaxy. He was the first person to do this because he had this insight, hey, I can take a shortcut and build a computer to do this. So it's a really cool story. And I think it's just a little bit of ingenuity and understanding about how we can kind of apply different things to different places. And through it, we get this beautiful video that I see Corey wants me to play.
Yeah, let's play the video.
So if you go back, it is a YouTube video I've embedded in, which I think will work. It's this. And
this one here?
Yeah, I think it'll play properly.
Let's see if I can get it here. No?
I think you have to click. I don't really know.
Yeah, I gotta figure out how to do this here. I know there's a way to do it. Weird. You know what? I think they looks like they showed up as PDFs and not.
But I went back and embedded the video right in the slide. I can see the slide. I can see the video on the slides on my end. Maybe if you stop presenting mode instead of just showed it, because you shouldn't just see the play.
let's see here. How do I do that? Might be easier just to bring up the website and present that.
I'll try to get that link.
Yeah.
I'm putting it in the chat.
Perfect. Corey's grabbing popcorn. Thanks, Corey. Give some to us as well.
It's the perfect time to run to concessions and grab a little snack.
I'm gonna say the thing that just occurred to me too about the light bulb story is that everyone was guessing so early because the idea and invention of the computer predates our understanding that galaxies are composed of stars. That's why that had to come so much later, because we didn't even know that was true until like the 30s or 40s. We hadn't thought about a computer in the 1800s, right? So
the big Hubble-Shapley debate in the 1920s.
Exactly.
They were called nebula. They thought all the galaxies were inside our own Milky Way.
Right.
So
we would have definitely have thought of a computer before that, which is crazy to think about. We thought about how to program circuits to I don't know. I never appreciated that point of that story before.
I've got the video.
Woohoo.
And
so these are fancier computer simulations now. More than 72, but still definitely less than 200 billion points.
Yes.
Can you all see that now?
Yeah.
Okay, let's do this. Here we go.
This is such a nice combination of simulation, observation, and kind of artistic, really converting that message into an image that's quickly, this is a video on YouTube. And what it's doing is it's flashing between the simulation and then finding an observation. And this is just one simulation moving forward in time. And yet you're getting to do exactly what I said, comparing to different galaxies that we see. So here the camera is just reorienting so that we can see what this interaction looks like from a different perspective that matches real galaxies interacting in the universe.
That's super cool.
And so they just pause the camera every point that they get that match. And so, these galaxies are literally billions of light years away from each other. And so, it's just kind of a coincidence that, well, not a coincidence, right? This interactive process is kind of something that usually looks a certain way. And so you can find multiple examples of it in nature, in the universe.
So cool.
I definitely should credit Frank Summers, who did this work of making this beautiful visualization of both the simulation and observational data.
Yeah, that's extraordinary.
Mm-hmm.
Are we going to end up out on one of those far-flung arms?
So there's people that are doing this. They're simulating what the Andromeda and the Milky Way interaction will look like in a couple billion years and figuring out what would it look like on Earth. And, we will stay around the sun. Galaxies have so much empty space between the stars that it's not going to really affect us. But yeah, our sky will look crazy. And who knows where our star will end up.
No more Zodiac. That'll all have to change.
Yeah, you can kiss the Zodiac goodbye.
Yeah.
Well, that was cool. I'm glad we took the time to check that video out.
Yeah.
Mm-hmm. Mark, do you have some more stuff you want to show us on some other slides?
I don't. I didn't bring anything else over.
That's really cool. Yeah, I mean, I guess technically, it's past 7 Mountain Time, but I always like to give the last word to the special guest. So if you have any words of wisdom or lessons learned or any other thoughts that you'd like to leave us with.
Well, just thinking a little bit of one of the themes of today. I know you kicked it off by, what was it called? NASA and LGBT, or in Canada we call it 2S LGBTQIA+, the full alphabet mafia, as we like to call it here. And it makes me think too of just, who's part of doing our science. And I think it ties into the idea that I always like to focus on when doing the outreach. It is an opportunity to hopefully engage people that maybe haven't been engaged for whatever reason in the process. And what we find, whenever you bring new people to the table, you start having new ideas and you make new innovation. And so on top of just, the moral necessity of including everybody in our species and part of the processes that we do like science, it also leads to amazing and better science when we do it. And so, I just encourage everybody, whenever you have the opportunity, if you're doing science out there, find an opportunity to share it with the world.
I love it, man. That is a great place to leave it tonight. Snaps to that. Mark, thank you so much for joining us this evening. It has been a pleasure. Our operations director, Maggie, will reach out to you with a thank you gift. So thanks again for your time.
Thank you.
Valerie's is right up there behind her. They're pretty fancy astrophotography prints made by the Wyoming Stargazing Board of Directors Vice President, Mike Adler. He is quite a astrophotography aficionado. He knows his stuff. So yeah, enjoy your print. And thanks as always to the co-stars for being here. Wouldn't have the show without you. So thank you so much for your time as always. And thanks to all the folks behind the scenes. Maggie, our operations director, the Wyoming Stargazing Board of Directors, all of our donors, and those of you who are watching this live and who will watch this as a recording. We hope you enjoy the show, and we'd love to hear from you. So chat your comments, ask questions, and we hope to see you next time in a couple of weeks. Until then, be well, and don't forget to look up. We'll see you next time.
Happy birthday, Samuel!
Thank you!
Happy birthday.